Hello everyone. Now our question is why electric field lines are perpendicular to surface of conductor. To understand this question, now we are taking a plain sheet of charge having three charges. Let the first charge is this Q plus Q, and this charge is plus Q, and this charge is plus Q, and the point of consideration at which we have to find out the electric field, let the point is be P. Now this point is at equidistance from this charge particle and from this charge particle. So the electric field at this point due to this charge particle will be in this direction. As we all know, the electric field due to a positive charge is radially outwards. So we can say that the electric field in this direction is acting like this. So the electric field this electric field is making angle theta with the horizontal, and the electric field due to this charge will be in this direction, as you can see here this arrow is pointing towards the two. So is this electric field is also making angle theta, and these electric fields are equal in magnitude because this point is equidistant from this charge particle and this charge particle. Let these electric field will are E2, and this is also E2, and the electric field due to this charge particle is E1. Now if we have to break these electric fields E2 into its components, into its horizontal and vertical components, now this component will be, if this is angle theta, then this angle is also be theta, because these are, you all know, these are corresponding angles. So this angle will be also theta, and this component of this electric field will be E2 cos theta. And similarly, if this is angle theta, then it will also be theta, and this component will be E2 cos theta. As you can see, these horizontal components are equal in magnitude. Since E2 equal to these both electric fields are equal, so E2 equal to E2 and cos theta equal to cos theta, and these are in opposite direction, so these will cancel out each other, and the components and the vertical component due to this electric field will be E2 sin theta, and another vertical component of this electric field will be E2 sin theta. So these vertical components will add up to give the net electric field and at point P, and these horizontal components will cancel out each other. So if I am redrawing this diagram, so my electric field at point P will be in this direction, and the magnitude of electric field will be E1 plus 2E2 sin theta. So we can say that this electric field will be perpendicular to this plane sheet of charge. So here we can see these components, these E2 cos theta components are cancelling out each other. So we can see that these horizontal components, or another name of these components is tangential components. So we can say that tangential component of electric field which are the tangential components E cos theta, or simply in simple words we can say E2 cos theta or E cos theta equal to 0. Now these E and cos theta are in product. If their product is 0, so either E is 0 or cos theta is 0. As we can see in diagram, E is not 0 because there is some electric field due to this charged particle. So we can say that the value of electric field is not 0. Therefore cos theta must be equal to 0. So therefore cos theta must be equal to 0 since E is not equal to 0. E not equal to 0, therefore cos theta. So to make cos theta equal to 0, theta must be equal to 90 degree because cos 90 equal to 0 degree. So we can say that therefore we can say that E is perpendicular to surface of conductor. Now there must be a question arises that if it is a plane sheet of charge, then it is perpendicular to surface. What will happen if the surface of conductor is let us suppose spherical? So if the surface is spherical, then charges would be like that, and if the charges would be like that, let us suppose the point of consideration will be this, and the electric field due to this charge at this point will be this E1, and the electric field due to this charge will be this E2, and the electric field due to this charge will be along this direction. So again these components, this will be theta. Similarly, according to the next question, previous situation, according to the previous situation, this component E2 cos theta will cancel out each other, and the resultant will be in vertical direction E1 plus 2E2 cos theta. So we can say that in spherical condition also the electric field will be perpendicular to the surface of conductor. Now let us suppose if your surface is concave in shape, let us suppose your conductor is like that. So we have to check whether in this case at this point P whether electric field is perpendicular to this surface or not. So let us suppose if this is the surface and charged particles are like that, so the electric field due to this charged particle will be in this direction, and the electric field due to this charged particle will be in this direction, and the electric field due to this charged particle will be in this direction. So if the electric field is this E, and this will be E2 and this will be E2, and the components of electric field will be this theta, this E2 cos theta. So we can see here that here also E2 cos theta will cancel out each other, and the net electric field will be in this direction, E plus E2 sin theta plus E2 sin theta. So here also we are seeing that the horizontal components are cancel out each other, and the net vertical components will be perpendicular to the surface of this conductor. So we can see here that in each and every case the electric field is perpendicular to each other. But to answer the question in examination, you have to write only this, because tangential components of electric field are equal to 0, therefore E cos theta equal to 0, and to make this happen, E is not equal to 0, therefore cos theta equal to 0, and E is not equal to 0, therefore theta equal to 90 degree. So we can say that E is perpendicular to surface of conductor. Or the another way of writing this question in examination is, we can say that in a conductor potential is constant, and if potential is constant and we have a definition of electric field equal to minus dV upon dr, and if this is the case, the another formula will become E dot dr equal to minus dV, because this dr will go here and it will become E dot dr equal to dV. Now what is dV? dV is change in potential, but we can say here we can see here that electric potential is constant in the surface of conductor. So conductor, in the case of conductor, in the case of conductor, V is constant because these are equipotential surfaces, and on equipotential surfaces V is constant. If V is constant, then change in potential will be zero. Therefore dV equal to zero. dV equal to zero. Why the dV equal to zero? Since V is constant. If V is constant, therefore E dot dr equal to 0. And this dot product, if we open this constant dot product, it will become E dr cos theta equal to 0. So if cos theta equal to 0, then we can say that E is not equal to 0 because there must be electric field due to a charged particle, and dr, the distance, it is also positive. So therefore cos theta will be equal to 0 because this product can only be 0 if any one of these is 0. So therefore cos theta equal to 0, and it will happen only if theta equal to 90 degree. So therefore E is perpendicular to surface of conductor. So in examination you can give answer either in this way, or in this way, either in this way. You have to write tangential component e to cos theta equal to 0, then theta equal to 0, and you have to write here, or you can solve like that. Thank you.